Today we're going to cover properties of quadratic functions in standard form. Let's go over some vocabulary fairly quickly. Remember, most of this was covered in the last video, but we'll still cover it really fast. The quadratic equation in standard form is ax squared plus bx plus c. Remember the difference between an equation and a function. Y equals is an equation and f of x equals is a function. Otherwise, they're the same. The graph of quadratics is a parabola, meaning it's U-shaped. The a value, the number in front of the x squared, determines whether the parabola goes up or opens down. A positive a value opens up. It's positive because it's holding your water, and a negative a value opens down, and that's negative when it spills your water. The zeros are the x values that makes the equation equal to 0. Basically, they're your x-intercepts. Your y will always be 0 at your x-intercepts. They're also called the roots or the solutions to the equations. The line of symmetry is the line that goes directly through the center of your vertex or the center of your parabola. There's a mirror image from left to right when you're going through the line of symmetry. The vertex is the center point. Vertex is always x, y. It's going to be either the lowest point with a positive a or the highest point with a negative a. We call that the minimum and the maximum values. The least possible y value or the greatest possible y value will always be the y value of your vertex. The line of symmetry is always the x value of your vertex. We're going to find the zeros, the y-intercept, the vertex, the line of symmetry, the min-max, domain, and range. The zeros are when you cross the x-axis. Because this graph doesn't cross the x-axis, there are no zeros. The y-intercept is where you cross the y-axis. We cross the y-axis right there at -2, so we're going to have 0, -2. Remember, whenever we cross the y-axis, our x value is 0. The vertex happens to be the same. Our vertex is our highest or lowest point. It's also at 0, -2. The line of symmetry is the imaginary line that goes through the middle of the vertex. It's going to be a line, so it needs to be an equation of the line. Remember, the line of symmetry is the x value of the vertex, so our line of symmetry is going to be x is equal to 0. Vertical line through 0. Minimum or maximum, this has a maximum value right here at -2. The graph isn't going any higher. The graph is opening down, so it's going to go down forever. So we have a maximum value, and remember, your maximum and minimum are always going to be the y value of your vertex. We have a maximum at y is equal to -2. The domain and the range. The domain are the x values that are covered by the graph. The domain's pretty easy because it's always the same answer. We're starting here at 0 and we're going, and it keeps going farther and farther to the left. The arrowheads means it goes forever. So this is going to go forever to the left, and then the same thing is going to happen to the right. It's going to go forever to the right. So the domain for all of these will be all real numbers. If you're going to write it in set notation, you'll say from -infinity to +infinity. The range is always going to be the y value of the vertex. So your range is your y value of the vertex. You need to look at which way it's going. It's going down, smaller numbers. So you'll say y is less than or equal to -2. Pull the -2 from the vertex. Sometimes they write it y such that, the vertical line is such that, and we put fancy brackets. Now, if we're going to write it in set notation, we're going to see where we started. Well, we started at -infinity and we're going up. Remember, we always go from smaller to larger. So we started at -infinity and we're going up to -2. The -2 is in brackets because of the or equal sign. It's equal to -2, and we can never be equal to infinity, so we use the parentheses. The zeros for this one are shown with giant dots. They're at -1, 0 and 3, 0. The y-intercept is right here, and that's going to be at 0, -3. The vertex is going to be the highest or lowest, in this case the lowest point, and that's at -1, -4. The line of symmetry is the imaginary line going straight through the middle of your parabola, and that's always going to be the x value of the vertex. X is equal to -1. Minimum or maximum. We are at the bottom right here. It's not going to go any lower, so we have a minimum. That means we're going to have a positive a value and the graph is opening upwards. The minimum is always going to be the y value of your vertex. So we're at y is equal to -4. The domain for all of these are the same answer, all real numbers, or from -infinity to +infinity. The range, again, the range is the y value of your vertex. So you're going to say y such that y is greater than or equal to, because we're going up, so it's greater than or equal to -4. Now if we put it in set notation, where are we starting? We're starting at -4, so we'd say -4 in a bracket, because the equal to, comma, infinity, with a parenthesis, because we can never hold on to infinity. Here's one more. I would strongly suggest pausing the video and trying to do this on your own, and then coming back and seeing if you did it correctly. First, the zeros. There's 1 0. We touch the x-axis at one point, which is -4, 0. The y-intercept is off the graph. If we have an equation or create an equation, we can find it, but that's not what we're working on now. The vertex is at -4, 0. Notice that the zeros and the vertex are the same. This is always true when you only have 1 0. Our line of symmetry is the x value of your vertex, that imaginary line that's going through. So we will have x is equal to -4. Next, does this have a minimum or a maximum? We're at the lowest point, it's opening up, so this has a minimum at your y value of the vertex. Y is equal to 0. The domain is always going to be the same, all real numbers, or from -infinity, to +infinity. The range is, again, the y value of your vertex. So we're starting at 0. Y is greater than or equal to 0. Sometimes your book will want it that way. Sometimes they'll want y such that with the brackets. And then sometimes we need it in set notation. We started at 0, infinity. Every once in a while you'll see a question like this. Without graphing, determine if the point is on the line. In order to do these, all you do is substitute and solve. So we'll just do one example. The equation was y equals 1/2 x squared plus 8. So we have an x value and a y value. 16 equals 1/2 4 squared plus 8. I simply substituted. Now I'm just going to solve. This is a true statement. 16 does equal 16, so your answer will be yes, the point is on the graph. If it was a false statement, then you would say no. Finding the line of symmetry. Remember, the line of symmetry is just the x value of the vertex. The formula is x equals -b over 2a. First step, put the equation in standard form. We always will put it in the correct form. In this case, ax squared plus bx plus c. We're going to be writing our ABCs for pretty much every equation from now on, and then you simply substitute and simplify. If I'm going to rewrite this, I get y is equal to 3x squared minus 4x plus 2. My ABCs, the a value is equal to 3, the number in front of the x squared. The b value is equal to -4, the number in front of the x, and the c value is equal to 2, the number at the end. Now I simply plugged it into my original formula. X is equal to negative. My b value is -4. Be careful of the two negatives. Over 2 times my a value, which is 3. 2 negatives gives me a positive, so that's 4 over 6. We always reduce 2/3. So my line of symmetry, or my axis of symmetry, is x is equal to 2/3. Which brings us into finding the vertex. Well, the line of symmetry is the x value of the vertex. So to find the vertex, the first thing we do is find that line of symmetry, just like we did, and then we substitute and solve for y. So to find the line of symmetry, we have to start by putting it into standard form. So that means I'm going to have to add the x squared to the other side, which gives me y is equal to x squared plus 4x minus 7. Now I write my ABCs. A is the value in front of the x squared, which is 1. B is equal to 4, and C is equal to negative 7. When I plug that in, I get x is equal to negative b over 2a, which is simply negative. My b value is 4 over 2 times 1. It gives me negative 4 over 2, which is simply negative 2. So x is equal to negative 2. Now I plug that back into the equation and figure out what the y value is. Y is equal to, whenever you substitute, you always use parentheses, negative 2 squared plus 4 times negative 2 minus 7. So y is equal to negative 11. Our answer is an ordered pair. So we always write in an ordered pair, x comma y, our x value is negative 2, comma, our y value is negative 11. Now, occasionally you'll come across a question that asks you to find the y-intercept simply off of an equation, and they're not asking for anything else. Remember, the y-intercept is when x is equal to 0. So all you have to do is plug a 0 in for x. So for this problem, we'll have y is equal to negative 5 over 8, parenthesis. We put a 0 in for the x, minus 8 squared. And then you simplify. I multiply straight across, 5 times 64 and 8 times 1. But before I multiply, I can cross cancel. That becomes a 1 and that becomes an 8. And that gives me negative 40. The y-intercept will be at y is equal to negative 40, or if you're putting it in ordered pair like they ask, then you would say 0, comma, negative 40. If possible, always check your answer. And we got it right.